Hello and welcome to this short demonstration on our condition monitoring sensor MPB10 for vibration analysis. We would like to show you how to use our sensor to detect an imbalance on your rotating machinery. Monitoring the condition of essential production equipment is crucial to prevent expensive failures. If rotating equipment like asynchronous motors are not monitored properly, wear and tear can result in damage or even complete production shutdowns. With the MPB10, you can detect faults in their early stages so that there is enough time to act before serious damage occurs. To demonstrate this, we equip a test stand with an imbalance. To detect this failure, we mount the MPB10 and analyze the corresponding vibration data. The test stand consists out of an electric motor which drives an axis. On this axis are two bearings and a rotating disc. Thanks to its small size, the MPB10 can be mounted easily with an adapter plate on the first bearing housing. Please keep in mind to align the sensor axis in axial and radial direction of your machinery. The system speed is set to 3000 RPM, which is equal to a 50 Hz AC frequency. To display the data provided by the sensor, we connect the MPB10 with our C-Link master and visualize the data via 6 SOPAS engineering tool. Here we see a moderate vibration values in time domain. In detail, we observe the strength and the energy contained in the vibration by looking at the magnitude of the ARMS and the VRMS. Additionally, by looking at the frequency domain, we can monitor the running speed, so-called 1x. This peak is expected at 50 Hz, which represents the 3000 RPM. Now we start to manipulate the test stand with an imbalance by equipping the rotating disc with a screw. By looking at the time domain values, we can instantly see the difference in the energy contained in the vibration. The values increased, especially the VRMS magnitude is way higher than before. This is an indicator for a change in a low-frequent vibration range. So the strength and the energy in the vibration are higher than without the imbalance. As the MPB10 is a triaxial sensor, the direction where the change is coming from can be identified. So the vibration is mainly occurring in radial and not in axial direction. To see if it is really an imbalance, we need to look at the frequency domain again. So in comparison to the proper working machine, the high peak at 50 Hz increased drastically. So as a summary, the VRMS and the ARMS are good indicators to judge the overall energy within the vibration. Especially for low frequency ranges, the VRMS is relevant. For high frequency ranges, the ARMS. A high peak at the rotational speed frequency and the vibration mainly in radial direction are good indicators that there is an imbalance problem. The MPB10 can also be integrated in condition monitoring systems by using SIG gateways and software solutions. These enable a long-term and real-time monitoring of your assets to prevent unplanned downtime.